Section 10.1 is called Applying the Accounting Principle and Permutations, and it's a quite logical section, and probably a lot of the stuff you've actually done before, so it's really not anything too challenging. So first of all, what is a permutation? And a permutation is an ordering of n objects. So if I have 10 people in front of me and I want to know how many ways I can order them, that would be a permutation. I'm going to add on to here something with this definition is that the order is going to matter. And if you think about 10 people in front of you, if I line them up A, B, C, D, E, F, G, etc., if I switch around A and B, it's going to be a different order. And if I, and that's just why order matters. That's what I mean by when I say order matters. Factorial, my guess is this is probably something new to you, is represented by the symbol, and it looks like an exclamation mark, which it is, but it doesn't mean what you think it means. It means mathematically that you're going to take that number times the previous number, times the previous number, times the previous number, blah, 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 all the way until you get down to 1. So, for example, it's very simple. If I had 8 factorial, that means I'm going to take 8 times 7 times 6 times 5, blah, 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 times 4 times 3 times 2 times 1. And obviously that will be a very large number. While I'm here, I'm going to have you find factorial on your calculator. Okay, so I have the directions up here. If you have an 83 or 84 calculator, from your home screen, you want to type in the number 8 first. And then after you type in 8, you go to Math. And then you arrow over, right arrow or left arrow over to PRB. And then you should see number 4, there's an exclamation mark, which is, of course, your factorial. And then when you press enter, you get 40,320. 89, same thing, so you type in the 8, and then you go second 5, which is your math button. And then you should see a PRB for probability, or actually I think you might see the word probability. And when you go there, you should also see the factorial. So again, the answer is 40,320 for 8 factorial. All right, the fundamental counting principle is actually a very simple idea. If you have 2 events, so for example, if I say one event can occur in m ways and another event can occur in n ways, then the number of ways that both events can occur is m times n. If you have 3 or more events, and don't bother writing this one down, it's just going to add another event. So if you know that one event can happen m ways, another event can happen n ways, and a third event can happen p ways, then the number of ways that all 3 events can occur is m times n times p. So fundamental counting principle is basically just multiply all of the events. Now, the key to this problem is that you want one of each of the events, and we'll look at an example next. So here it says you're buying a pizza. You have a choice between 3 crusts, 4 cheeses, 5 meat toppings, and 8 vegetable toppings. How many different pizzas with 1 crust, 1 cheese, 1 meat, and 1 vegetable can you choose? So the key idea to the fundamental counting principle is this. You want one of everything. If I wanted 2 cheeses or 3 meats or 4 vegetables or, whatever, then the idea changes, which we will cover eventually. So I want you to understand that with the fundamental counting principle, you want one of everything, okay? Or one of however many objects. So here, I'm really, again, fundamental counting principle just says you're going to multiply your options together. So 3 crusts times 4 cheeses times 5 meats times 8 vegetables. And that equals 480 different pizzas you can make. Okay, you try this one, pause the video, see what you get. and you should have got 216 different pizzas. So again, 6 cheeses times 4 meat toppings times 9 vegetable toppings. Okay, this one's a little bit different. This says a town has telephone numbers that all begin with the 329, followed by 4 digits. How many different phone numbers are possible if the numbers can be repeated and if the numbers cannot be repeated? Okay, so if they can be repeated, so my number is going to be 329, and then it's going to be 4 numbers, and I can repeat my digits. So if you think about your digits, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So you've got 10 digits altogether, not 9, right? Because we include 0. So I have 10 options for my first number, and then I have 10 options for my next number because I can repeat them, and then I have 10 options, and then I have 10 options. So basically I have 10 to the 4th power there, or 10,000 different ways I can arrange those last 4 digits. Now, if they cannot be repeated, then my phone number is going to be 4 numbers, so I have 10 digits to choose from, but then I can't reuse that first digit, so then I only have 9 to choose from, and then I can't reuse the 2 previous, so I'm down to 8, and then I can't reuse the 3 previous, so I'm down to 7 numbers to choose from. And if I multiply all of those together, you get 5,040 different phone numbers. So again, the first one was, I could repeat those, so 10 times 10 times 10, and then in the second option I couldn't repeat them, so it went down 1 digit each time. Alright, this one says, you have 8 teams are competing for a baseball playoff. Okay, so the part A says, in how many different ways can the baseball teams finish the competition? So you've got 8 teams. How many ways can they finish the competition? So I have 8 spots to finish. Well, I have 8 teams that could, take the last place position, I suppose is how you would look at it. And then somebody's going to get last place. Then I only have 7 teams left to choose to get the next second to last. And then I have 6 teams to choose from. And then 5 teams, and then 4, and then 3 teams, and then 2. And then, of course, I'm down to the winning first place team. Now, this is the same as 8 factorial, which you probably recall is 40,320 different ways these baseball teams could finish the competition. So really, if you want, in how many ways can you order something, and you want to use every single possible thing, in this case teams, then it's always just that number factorial. However, in part B, it says how many different ways can 3 of the baseball teams finish first, second, and third. Well, now I'm only looking at the first 3 finishing positions. Well, technically 8 teams can finish first, but then somebody gets first place, so then only 7 teams can get second, and somebody gets second place, so then there's only 6 teams left to get third place. Now, this is not 8 factorial, which I'm sure you realize, so just be careful, and this answer, by the way, is 336. So be careful with this because you don't use all the teams here, so you can't do 8 factorial. Okay, you try this one on your own. Pause the video and see what you get. It says how many different 7-digit telephone numbers are possible if all of the digits can be repeated. So if you can repeat, you have 7 digits. I'm sorry, you have 10 digits to choose from, but you have a 7-digit telephone number, and they can all be repeated. So basically you have 10 options every single time. So the fundamental counting principle says multiply those together, which would be 10 to the 7th, and that would be 10 million different phone numbers.